So today we're going to be starting chapter 10. And the first section in chapter 10 is sequences as functions. So what is a sequence? Well, a sequence is a set of numbers in some sort of a order or pattern, right? And every number in a sequence has a special name. We call it a term. So there's two types of different sequences. Well, there's lots of different types of sequences, but specifically, there are sequences that end. Those are called finite, right? And so we think of finite as like, cards in a deck, right? Or there's sequences that are infinite or infinite. Okay, and infinite sequences go on forever, right? So a sequence as a function is a sequence that's domain is a natural number, meaning it starts at 1, so the first term, second term, third term, and so on. They go up by whole numbers, right? Starting at 1. In the range, the values in my sequence are real numbers, right? They can be positive, negative, whole numbers. They can be decimals. They can be fractions. They can be square roots. They can be all kinds of different things, right? So that's what those are our terms, right? So we have our first term, and then we have values, right? And so, so the first set of numbers that we're going to look at, our first sequence, is called an arithmetic sequence. So in an arithmetic sequence, each term is determined by adding some value to be the same. So let's look at a quick example. So like if we look at this one right here. So if I'm going from 3 to 6, 6 to 9, 9 to 12, and 12 to 15, I'm going up by 3 every time. And that constant value that I'm adding every time has a special name. We call it the common difference. Okay? So in our case, or that example that we just looked at, the common difference would be 3 because I'm adding 3 every single time. So let's look at an example. Okay, so first example, it says, determine whether this sequence is arithmetic or not. So I look, and I'm going from 5 to negative 6. So what do I add to 5 to get negative 6? Well, if you're not sure how to do that off the top of your head, it's fine. You can go to your calculator. You take the second term, so in our case, negative 6, and you subtract the first term, which would be 5. And you see it goes down by negative 11. Let's go to the next one. From negative 6 to negative 17, that also goes down by 11, or adding negative 11. And same thing from 17 to 28. So I'm adding, I have a common difference every single time of negative 11. So this is arithmetic. Okay? That one's arithmetic because I'm adding negative 11 every single time. Now let's look at the next problem. Okay? So negative 4 to 12, if I want to figure out what I'm adding to it, I would take 12 minus a negative 4, and I get 16, right? And so if I added 16 to 12, I get 28. So that works. If I add 16 to 28, I get 44. But this is 42. So really that one's adding 14. So do I have a common difference the whole time? I do not. So this one is not arithmetic. Okay, because the common difference is not the same. So now we're going to look at an arithmetic sequence, and we're actually going to find the next couple terms of it. So if I look at this one right here, it starts at 18. That's my first term. And the next one's 14. The next one's 10. I can figure out my common difference. I call it D. And I do that by taking 14 minus 18, or the second term minus the first term, and I get negative 4. So my common difference, what I'm adding every single time, is negative 4. So if I wanted to find the next term, I would take 10 plus negative 4, and that would be 6. I'd take 6 plus negative 4, that would be 2. I'd take 2 plus negative 4, that'd be negative 2. And then negative 2 plus negative 4 is negative 6. So those are my next 4 terms in my arithmetic sequence with common difference negative 4 starting at 18. So in part B of this example, they ask us to graph the 7 terms. So what that means is I have to figure out how to graph these. So if I think of them as x's and y's, going by term, right? And I said, okay, well, my first term, so we said it started at 18, right? Starts at 18. Then the next one was 14. Then I added another negative 4 common difference. I get 10, 6, 2, negative 2, negative 6. Those are all points that I could graph. And so if I say that these go up by 2s, that my y values go by 2s, my x's go by 1s, I would get 1, 18, 2, 14, 3, 10, 2, 4, 6, 8, 10, okay, 4, 6, 5, 2, 6, negative 2, and so on. And you'll see that my graph, though it's not a good one, is a straight line. So when we have a common difference in an arithmetic sequence, when I graph it, it's going to be a straight line, okay? Now, let's apply this to a word problem. So it says, a marching band marches in rows. And the first row has 1 performer. The second one has 3 performers. So if we think of this, 1 performer, then 3 performers, right? And then the next one has 5, 2, 3, 4, 5. And then the next one after that, we'd have to figure out the next. And it says, figure out how many performers will be in the 14th row. So how do you think we could do? I mean, we could count it, right? So we've had, 3 rows. We go the 4th row and the 5th row and the 6th row and so on and so forth. But there's actually an easier way to do this. So I'm going to think about it kind of in terms of a line, because we said it looks like a line, right? So what am I adding every single time? Well, I'm adding 2 every time. So that must be somewhat important. So if I look at my first row times 2, I get 2. But I'm supposed to have 1 in it. So what would I do to 2 to get it to 1? Well, I would subtract 1. So let's try the next, I get 1. Let's try the next row. So that would be row 2. Common difference, adding 2 every time is 4. Well, that equals 4, but then I take away 1 and I get 3. Well, that's kind of cool. So let's look at the next one. The third row times 2 is 6 minus 1 is 5. And that is how many are in the next marching band row. So how do you think we can figure out the 14th row? Well, what we're going to do is we're going to say, well, these were the number of rows, right? So I'm going to take the 14th row. Okay, I'm going to say the 14th row times 2 minus 1, right? Because I multiplied it by 2 and then subtracted 1 every time. So 14 times 2 minus 1 is 27. So how many performers would be in the 14th row? 27 performers. And we can do this with any arithmetic sequence, thinking of it the same way. As long as we know at least at least we know at least 2 of our terms, we can figure it out, okay?